Hello Junior Techies, my name is Natasha Barton and I would like to welcome each of you to the last video in this series of videos on atomic combinations, molecular structure. In this video, we are going to bring together all of the concepts that you have learned so far as we will be practicing exam problems. Junior Techies, on the Junior Techie website, you can access a theory booklet, a worksheet, and a memo to that worksheet, which you can use to practice for your tests and exams. So I hope that you will download these worksheets so that you can make the most out of your learning and get the marks which you would like to obtain. Throughout this video, I will be making use of questions from the Department of Basic Education's November 2019 Paper 2 exam. All of the questions total to 19 marks. This video will therefore be a bit longer than the practice videos. So if you find that you lose concentration along the way, don't be scared to pause the video and return to it a bit later. Throughout the video, I will use blue pen to show the answers that will obtain you your marks. I will use pencil to show the mental work, the thought processes, the rough work. But I would like to emphasize that I do not recommend that you first write in pencil, then erase and write in pen in your exams and tests. This is a waste of time. I'm only using a pencil here so that you will know exactly what will get you your marks. I will then use a red pen to show the mark allocations. Question 1 says, ammonia and hypochlorous acid are both examples of covalent compounds. Question 1.1 says, define the term bonding pair. Ladies and gentlemen, it is very important that you learn the definitions that your teacher says you should learn off by heart. Not all of the definitions given in your textbook will get you full marks, so always pay attention to the instructions given to you by your teacher. We say that a bonding pair is two electrons shared between two atoms in a covalent bond. And for writing this down, you will obtain 2 marks. Question 1.2 says, draw Lewis structures for the molecules. In question A, we are dealing with ammonia, that is NH3. In order to solve this problem, we will need a periodic table. So if you have one close by, bring it even closer and use it in order to solve these problems with me. Sometimes some exam questions will say that you must use both dots and crosses in order to answer these questions. Again, it is very important that you follow the instructions given to you. From the periodic table, we find that nitrogen has 5 valent electrons, and each hydrogen atom has 1 valent electron. In the theory booklet, there's a long list of steps that you can follow to draw Lewis structures, but these steps are not always necessary. Most of the time, it will be sufficient to just pair up unpaired electrons, and that is what we will do in this video. We pair up the unpaired electrons as displayed to your screen, and we obtain the correct Lewis structure for ammonia that you can now see on your screen. For drawing this, you will obtain 2 marks. Notice that each hydrogen atom is satisfied with only 2 electrons because it is an exception to the octet rule. But if you count the number of electrons around nitrogen, you will find that there are 8 electrons, meaning that the octet of nitrogen has been satisfied. In question B, we need to draw the Lewis structure for hypochlorous acid. This contains a hydrogen atom, an oxygen atom, and a chlorine atom. Hydrogen has 1 valent electron, oxygen has 6, and chlorine has 7. Both hydrogen and chlorine will always be terminal atoms. This leaves us with oxygen as the central atom in this molecule. We again pair up the unpaired electrons, bringing us to the correct Lewis structure for hypochlorous acid that is currently displayed to your screen. For this, you will obtain 2 marks. And notice over here that although again hydrogen is satisfied with 2 electrons, both oxygen and chlorine are surrounded by 8 electrons because they need their octet to be satisfied. Question 1.3a says, write down the number of bonding pairs in ammonia. So in order to do this successfully, we need the Lewis diagram that we drew in question 1.2. Using this, we can count that the number of bonding pairs, remember bonding pairs lie between atoms and they are responsible for the bond that forms between these 2 atoms. We can count the number of bonding pairs in our Lewis diagram, and we find that in ammonia there is 1, 2, 3 bonding pairs. So the answer to question 1.3a is 3, and for this you obtain 1 mark. For 1.3b, or in question 1.3b, they want us to write down the number of lone pairs on the oxygen atom in hypochlorous acid. So here in this question, we are going to need the Lewis diagram for hypochlorous acid. So I've copied that down from question 1.2. We can now count the number of lone pairs on the oxygen atom. Be careful, there are also lone pairs on the chlorine atom, but we want the lone pairs on the oxygen atom, which we count as 1, 2. There are 2 lone pairs on the oxygen atom. The other 2 pairs are bonding pairs between oxygen and hydrogen and oxygen and chlorine. So the answer to question 1.3b is 2. And for writing this down, ladies and gentlemen, you obtain 1 mark. In question C, we need to write down the shape of the ammonia molecule. We already have a diagram, the Lewis diagram of ammonia, which I've brought in from question 1.2. When you want to determine the shape of a molecule, you start off by drawing the Lewis diagram, and once you have the Lewis diagram, you complete the general formula. Over here, for ammonia, we have the central atom, nitrogen, which we represent as A. Around nitrogen, we have 3 terminal atoms, 3 hydrogen atoms, which we represent with the X, and the 3 shows that there are 3 terminal atoms. And we have 1 lone pair on the central atom. We only care about lone pairs on the central atom, which in this case is nitrogen. So we just write down E. You could write E subscript 1, but it's not necessary. And using this completed general formula, we know that the shape of the ammonia molecule is trigonal pyramidal. For writing this down, you obtain 1 mark. Question 1.4 says, which bond, the bond between nitrogen and hydrogen, or the bond between oxygen and hydrogen, is more polar? Give a reason for your answer. In order to solve this problem, we will be required to calculate the difference in the electronegativities of the atoms contained in each bond. Let's start off with the bond between oxygen and hydrogen. We always take the bigger electronegativity and subtract from it the smaller electronegativity. Oxygen has an electronegativity of 3,5. Hydrogen has an electronegativity of 2,1. So we say 3,5 minus 2,1 and obtain an answer of 1,4. We perform a similar calculation for the bond between nitrogen and hydrogen. The electronegativity of nitrogen is 3, while that of hydrogen is still 2,1. 3 minus 2,1 gives us an answer of 0,9. 1,4 is bigger than 0,9, and we can therefore conclude that the bond between oxygen and hydrogen is more polar. You will obtain 1 mark for stating this and 1 mark for your calculation. In the marking guidelines of this question paper, they acknowledge the calculation as a reason for your answer. But you may also state in words that the reason why the OH bond is more polar is because the electronegativity difference between hydrogen and oxygen is greater. We can now move on to question 1.5, which says, when ammonia, that is NH3, dissolves in water, H2O, the ammonium ion, NH4+, is formed. What type of bond forms between ammonia, the ammonia molecule, and the hydrogen ion? You should know from the practice videos of the dative covalent bond. A dative covalent bond forms when one atom supplies both electrons required for the bond to take place. In this case, the hydrogen ion, which has an empty orbital, will have its empty orbital overlapped with a lone pair of electrons from the nitrogen atom in the ammonia molecule. The type of bond that exists between the ammonia molecule and the hydrogen ion is therefore a dative covalent bond. And for writing this down, you will obtain 1 mark. Ladies and gentlemen, you will not obtain this mark for simply stating covalent bond. You need to state that it is the dative covalent bond, or you could call it the coordinate covalent bond. Question 2 says, the graph of potential energy versus distance between the nuclei of 2 oxygen atoms during bond formation is shown below. Here we have curves that I hope you all know how to analyze and understand very well, because they are explained in both a theory and practice video. Question 2.1 says, define the term bond energy. We can state that bond energy is the energy needed to break 1 mole of a compound's molecules into separate atoms. Ladies and gentlemen, it is very important that you learn the definition that your teacher says you should, or you will not obtain all of your marks. In this case, we get our marks from writing this definition down, and we get 2 marks for this. But again, if you do not write down the required definition, you might not obtain your marks. Question 2.2 says, which curve, A or B, represents the formation of the double bond between oxygen atoms? Briefly explain the answer. I would like to remind you that oxygen has a valency of 2. That means that oxygen is able to form a maximum of 2 bonds. This means that curve A and curve B either represent, so either one of them represents a single bond or a double bond. We don't have triple bonds forming in this case. So we need to analyze the 2 graphs and compare them to decide which one of the 2 is the double bond. From these curves, we can obtain bond length and bond energy. So let's do so for curve A and then do so for curve B. Reading off the y-axis of the graph, we find that the bond energy for the bond formed and represented by A is 494 kilojoules per mole. The bond length is 121 picometers. Analyzing graph B, we find that the bond energy here is 142 kilojoules per mole. The bond length is 148 picometers. Remembering what we know about single and double bonds, we find that the strength of a single bond is weaker than that of a double bond. The bond length of a single bond is longer than that of a double bond, and the bond energy of a single bond is smaller than that of a double bond. When we compare the values obtained when we analyze the curves, we find that the bond energy represented by curve A is larger than that of curve B. We found that the bond length from curve A is shorter than that of curve B, and we can therefore conclude that curve A represents the stronger bond and therefore that it represents the double bond. The answer to question 2.2 is therefore curve A. And the reason is when bond order increases or when a double bond is formed, the bond length decreases and the bond energy increases. You will get 1 mark for saying that curve A is the curve that represents the double bond, 1 mark for stating the relationship between bond order and bond length, and 1 mark for stating the relationship between bond order and bond energy. This gives you the 3 marks that you can obtain in question 2.2. We now move on to the last question contained in this video, which says, write down the bond length of the bond represented by curve B. Analyzing curve B and reading up to the x-axis, we find that the bond length is 148. But remember, bond length has a unit of measurement. In this case, the bond length is measured in picometers. Writing down the correct magnitude with its unit, we obtain the final mark in this video, and we finish off the last question contained in this video. Junior Techies, I would like to thank you all so much for taking your time to watch all of these videos. I really appreciate your effort, and I really hope that all that you've done so far is going to help you to do very well in your tests and exams. I hope that it helps you to understand physical science and enjoy it even more. Remember that in order to retain all of this information that you've learned, you now need to go and practice. Watching these videos is just not going to be enough, because we need to take all of this information from your short-term memory and plug it into your long-term memory so that it lasts for a long time. So please make sure, again, to download that worksheet, to download the memo to the worksheet from the Junior Techie website, and to practice as much as possible. I hope that you've enjoyed watching these videos as much as I've enjoyed creating them. Wishing you all the best.